Modern warfare is undergoing a profound transformation, moving beyond the traditional kinetic force of bullets and bombs. At the forefront of this evolution are directed energy weapons, or DEWs, representing a significant frontier in military technology. These innovative systems fundamentally differ from conventional armaments. Instead of relying on physical projectiles, they harness and project concentrated waves of energy. This energy can take various forms, from high-energy lasers to particle beams. Among the most impactful and rapidly developing types of directed energy weapons are high-power microwave, or HPM, systems. HPM weapons are specifically engineered to achieve a unique objective on the battlefield. Their primary design purpose is to disrupt, degrade, or outright destroy electronic systems. The strategic importance of HPM weapons cannot be overstated in today's interconnected world. Modern military operations are now overwhelmingly reliant on sophisticated electronics for everything from communication and navigation to targeting and command and control. This pervasive dependence on electronic systems, while offering immense advantages, simultaneously creates a critical vulnerability. HPM weapons are designed precisely to exploit this Achilles heel. By targeting and neutralizing electronic infrastructure, they offer a potent means of crippling an adversary's capabilities without necessarily resorting to destructive kinetic force. Recognizing this immense potential, the U.S. Department of Defense has made substantial investments in the research, development, and deployment of HPM technology. The promise of HPM is compelling: to neutralize critical electronic systems with precision. This capability allows for the disruption of enemy operations without the widespread destruction or collateral damage often associated with traditional explosives. It represents a paradigm shift in how conflicts might be waged and resolved. Understanding how HPM weapons operate reveals their elegant yet devastating simplicity. At their core, HPM weapons generate incredibly powerful, focused bursts of electromagnetic energy. This energy is fundamentally similar to the radio waves used by your Wi-Fi router or microwave oven, but at significantly higher power levels and with precise directional control. When these intense bursts of electromagnetic energy are directed at unshielded electronic systems, they induce powerful electrical currents within the circuitry. These induced currents are far beyond what the delicate components of modern electronics are designed to handle. The sudden surge of energy overwhelms the system's internal safeguards and operational thresholds. This overwhelming of circuitry leads to immediate and catastrophic failure. Components can be burned out, data corrupted, or entire systems rendered inoperable. The result is an effective and often instantaneous disabling of the targeted electronic systems, achieving a mission objective without physical destruction. The United States has been at the forefront of developing practical HPM systems, with several notable programs demonstrating their potential. One prime example is Epirus' Leonidas system, specifically designed to counter the growing threat of drone swarms. This innovative HPM weapon is engineered to provide a wide-area defense against multiple aerial threats. Leonidas operates by emitting a powerful, wide-angle microwave beam. This beam can simultaneously engage and disable numerous drones within its field of effect, offering a scalable solution to complex aerial attacks. Its ability to neutralize multiple targets with a single burst represents a significant leap in counter-drone capabilities. The U.S. Army has recognized the strategic value of Leonidas, awarding contracts for its continued development and integration into its indirect fire protection capability high-power microwave, or IFPC-HPM, program. This signifies a clear intent to field HPM technology for critical ground defense roles. Another pivotal system is Thor, developed by the U.S. Air Force. Thor, which stands for Tactical High-Power Operational Responder, was specifically conceived for base defense against drone attacks. It provides a robust, non-kinetic solution to protect critical assets and personnel from increasingly sophisticated unmanned aerial threats. These systems underscore the diverse applications and strategic importance of HPM technology across military branches. The advantages offered by HPM technology are numerous and compelling, setting it apart from conventional weaponry. One of the most significant benefits is the sheer speed and economy with which HPM systems can operate compared to traditional methods. They can engage threats at the speed of light, offering instantaneous response capabilities. Furthermore, HPM systems possess the unique ability to engage multiple threats in rapid succession, or even simultaneously. Unlike kinetic weapons that require individual targeting and firing for each threat, a single HPM burst can neutralize an entire swarm. This multi-target engagement capability is particularly crucial in scenarios involving massed attacks. Another critical advantage is that HPM systems do not require reloading, unlike projectile-based weapons. As long as power is supplied, they can continue to fire, offering sustained defensive or offensive capabilities. This eliminates the logistical complexities and vulnerabilities associated with ammunition resupply. Ultimately, HPM systems offer a rapid, cost-effective, and highly efficient defense against a wide array of modern threats. Their ability to neutralize targets like drone swarms without physical impact or extensive logistical tail makes them an invaluable asset for future military operations. They represent a paradigm shift in defensive and offensive strategies. The concept of directed energy weapons is not new. Research into these futuristic armaments has been ongoing for many decades. Scientists and engineers have long envisioned weapons that could harness and project energy rather than relying on chemical propellants. Early efforts faced significant technological hurdles, limiting their practical application. However, recent advancements across several key technological domains are now bringing HPM systems much closer to practical battlefield use. These breakthroughs have transformed theoretical concepts into deployable realities. The convergence of these innovations has made HPM a viable and increasingly attractive option for modern militaries. Key technological improvements include the development of significantly more powerful and efficient microwave amplifiers. These devices can generate the immense energy required for effective HPM attacks. Alongside this, advancements in antenna design have enabled precise focusing and steering of these high-power beams. These combined innovations are rapidly accelerating the deployment of HPM capabilities. Despite their immense potential, HPM weapons are not without their challenges and criticisms. One of the most significant hurdles is the substantial power requirements needed to generate and project effective microwave bursts. These systems demand large amounts of electrical energy, which can be difficult to provide in remote or mobile operational environments. Another critical factor affecting HPM weapon effectiveness is atmospheric interference. Environmental conditions such as rain, fog, or even dense humidity can absorb or scatter microwave energy, reducing its intensity and range. This can significantly degrade the weapon's performance, especially over longer distances or in adverse weather. Furthermore, the integration of HPM systems with existing defense networks presents its own set of complexities. These new weapons must seamlessly communicate and coordinate with established command and control structures, radar systems, and other defensive assets. Ensuring interoperability and avoiding unintended consequences requires extensive development and testing. These challenges highlight that while HPM technology is rapidly maturing, there are still significant engineering and operational considerations to address. Overcoming these hurdles will be crucial for the widespread adoption and reliable deployment of these advanced weapon systems. The path to full integration is complex but actively being pursued. The emergence of HPM weapons introduces a new layer of ethical and strategic considerations that demand careful examination. The ability to disable electronic systems without causing physical harm or loss of life raises complex questions about the nature of warfare. While potentially reducing casualties, it also opens new avenues for conflict. One major concern is the potential for HPM weapons to inadvertently affect civilian infrastructure. Modern societies are deeply intertwined with electronic systems, from power grids and communication networks to financial institutions. targeting military electronics broadly could have unintended and widespread consequences for non-combatants. The precise definition of what constitutes a legitimate military target in the context of electronic warfare becomes critical. International law and existing military doctrine, largely developed around kinetic warfare, will need to adapt significantly to accommodate this new class of weapons. New rules of engagement and ethical guidelines must be established. These considerations underscore the need for thoughtful deliberation and international cooperation as HPM technology advances. The responsible development and deployment of these weapons will be paramount to navigating the complex ethical and strategic landscape they create. Their impact extends far beyond the battlefield. The potential of HPM weapons to achieve electronic dominance is undeniable, fundamentally reshaping military strategy. This shift from relying solely on kinetic force to prioritizing electronic neutralization is driving significant investment globally. Nations worldwide recognize the strategic imperative of mastering this technology. The race to develop and deploy HPM systems is not confined to the United States. Other major powers, including the United Kingdom, China, Russia, and Israel, are actively pursuing their own advanced HPM programs. Each nation seeks to gain a strategic advantage in this critical domain, fostering a new arms race in directed energy. Currently, HPM systems are largely in testing and early deployment phases, demonstrating their capabilities in controlled environments and limited operational scenarios. However, the pace of development suggests a rapid transition to widespread integration. Experts anticipate that HPM systems will become a common feature on the battlefield within this decade. This widespread adoption could fundamentally alter the nature of warfare as we know it. The ability to cripple an adversary's electronic nervous system without firing a shot offers a powerful new tool for deterrence and conflict resolution. In a world increasingly defined by digital infrastructure, electronic supremacy may become as crucial as air superiority once was.